Hey everybody, I'm at my concert crowd surfing. Everyone's super excited to learn about adding and subtracting polynomials! Before we start today's lesson, we're going to review three basic concepts: like terms, unlike terms, and the distributive property. First, we have 5x squared plus 9x squared. They're like terms because they have the same variable and they have the same exponent. So you simply just add the coefficients. 5 plus 9 is 14, and 14x squared. You don't change the exponent. Same thing here. 3y to the third plus 2y to the third is really just asking how many y to the thirds do you have. 3 plus 2 is 5, so we have 5. And then if you look here, we have examples of unlike terms. Yes, they have the same variable as x, but they have different exponents. So 4x squared minus 3x cannot be combined. That is fully simplified. Same thing here, 5x to the third plus 2x squared, different exponents, cannot be simplified any further. And then last thing, the distributive property, in a specific example where you would just have a negative sign out in front. What that means is you can distribute a -1 to both numbers inside parentheses, which really all it's doing is changing the sign of everything inside. So that 3x is now negative, and the -5 is now positive. You'll need to understand these three concepts for today's lesson. We're going to do three examples in which we will be adding polynomials. I will work 2 out with you and give you 1 to try on your own. In the sets of parentheses, we have different polynomials that we're adding together. When you add polynomials, really the parentheses are not necessary because all you're going to end up doing is combining like terms. And then anytime you do anything with polynomials, your final answer has to be in standard form, which simply means your exponents will go in decreasing order, and then the number without the variable is always at the end. So for the first one, my like terms, I have 4x squared and 2x squared. Combine them together, it gives me 6x squared. And then I have a positive 6x. And take the sign in front always, I have a negative 9x. So that's going to give me a negative 3x minus 3x. And then I have a positive 7 and a positive 1. 7 plus 1 is 8. All I did was have to combine my like terms. My final answer is in standard form because my exponents go 2 and then 1, and then there's no variable at the end. Same idea for the second one. Combine your like terms. 7y squared, and then do I have any other y squareds? I've got 1 here, and I actually have 1 here. So 7y squared plus 8y squared plus 3y squared, which gives me 18y squared. And then look at all of my y's. I have a negative 3y, a positive 4y, and another positive 4y. So 4 plus 4 is 8, and 8 minus 3 is 5, so that's plus 5y. And there's nothing else to combine, so I'm done with that one. For this third example, I want you to write it down, pause the video, and try it on your own. You should have gotten 6a squared minus 7a plus 21. How'd you do? Now we're going to do three examples in which we will be subtracting polynomials. It's almost the same as adding, except we're going to add a step. Our steps are, we have to distribute that negative sign, well, the subtraction sign, to the second polynomial. It's just like adding the opposite, but to an entire polynomial. And then after you do that, you just simply combine like terms, make sure your answer is in standard form. So on this first one, if I distribute that subtraction sign over, or you could think about it as adding the opposite, you're simply just changing the sign in front of everything in that second polynomial. So when you rewrite it, the first polynomial stays the same, 2x to the third plus 5x squared minus 3x. But then the second polynomial, it's now minus x to the third that minus 8x is now plus 8x. And then plus 11 is now minus 11. So you change the sign of that second polynomial, and now you just go straight into combining like terms. I have 2x to the third and a negative x to the third, which will give me 1x to the third. And then a 5x squared. There are no other x squared, so I'm just going to bring that down into my answer, plus 5x squared. I can go into my x's. I have a negative 3x and a positive 8x, which gives me a positive 5x. And then all I have is a negative 11, nothing to combine it with, so there it goes at the end. Check to make sure everything is in standard form. I've got exponent 3, 2, 1, and then none. So there you go. There's my answer. Very similar, just adds one step at the beginning. Alright, so let's do the same steps. That first polynomial, we don't change, we just rewrite it. Negative 7x to the third plus 3x minus 1. And then for the second polynomial, distributing that subtraction sign, we're going to rewrite it except change the sign of all of our terms. So that negative 6x squared is now plus 6x squared, plus x is now minus x, plus 4 is now minus 4. Now let's just combine like terms. Negative 7x to the third, there are no other terms that have the power 3, so I'm going to bring that down. Negative 7x to the third. Do I have any x squareds? I do, 6x squared, and there are no other terms that have x squared, so I'll just bring that down, plus 6x squared. Let's see, I've got a positive 3x and then a negative x, so that's just going to be a positive 2x. And then finally I have a negative 1 and a negative 4. When I add two negatives I get a bigger negative, which is negative 5. And then it's in standard form, 3, 2, 1, and none. Now just like before, I want you to pause the video, write this one down, and try it on your own. Alright, for your answer you should get 5w squared minus 4w plus 10. That was easy peasy lemon squeezy. Party on and get to work.